So I think the habits of mind question here is really interesting. It says, is it possible for a quadratic equation to have one real solution and one complex solution? So let's explore this for a minute. Let's look at, well, let me get my pen here. Let's look at the quadratic formula. Pen gonna work? Come on, pen. Let's work. We got work to do. Okay, so here we go. Let's look at the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So when we've been working on this, we've been getting two solutions. And we end up getting two solutions because of the plus or minus right here. Because when I have the plus, it will say negative b plus whatever the square root is divided by 2a. So that the plus gives me one solution. The minus gives me the second solution. So negative b minus a number divided by 2a. So I get two solutions because there's a plus or minus in the formula. So that's where the two solutions come from. That's why we'll have two solutions, or can. Then it says, is it possible for the quadratic equation to have one real solution and one complex solution? That meaning one real number and one imaginary number as our answers? Well, let's look. In the quadratic formula, we have an expression under the square root. So let's think of the types of numbers that could be under a square root. And there's actually three kinds. So I'm just going to look at just the square root part. So I could have a positive number under a square root, the square root of a positive number. I could have a negative number under a square root. Or I could have, if it's not positive or negative, I could have a 0 under the square root. And then also notice that plus or minus is before the square root. So I'm going to bring the plus or minus out. So I'm only exploring that part underneath. Well, the square root of a positive number is a real number. So if I had a positive number under a radical, that would leave me to a plus or minus real number, which means plus or minus real number, that's two real solutions. Now, if I take the square root of a negative number, I'm going to get an imaginary number. And then I'll have the plus or minus that gets brought out in front, plus or minus an imaginary number. And if you have something plus or minus an imaginary number, that means you'll have a complex. So that's two imaginary solutions, but then if we add them to real numbers, this is going to lead me to two complex solutions. And then if you take the square root of 0, you're just going to get 0. And plus or minus 0 is still 0. And how many solutions is this? This is just one. This is one real solution. So is it possible to have one real and one complex? No. We can either have two real solutions, two complex solutions, or one real solution. So it all goes back to the number under the square root. If the number under the square root is positive, we're going to have two real solutions. I'll even highlight that. I think that's a good thing to highlight. Number under the square root is positive. That's going to lead me to two real solutions. If the number under the square root is negative, I'm going to have two complex solutions. And then if the number under the square root is 0, then I'm going to have one real solution. Now, who's tired of thinking about or saying over and over the number under the square root? Well, the number under the square root actually has a name. It's called the discriminant. It's called the discriminant. Discriminant. I've forgotten how to spell. It's getting late. As you can see, 9 o'clock at night. Okay. This is discriminant. So the discriminant is equal to, it's the number under the square root. The square root. Its formula is b squared minus 4ac. So the discriminant determines the number and types of solutions we will have. So the discriminant determines the number and types of solutions. So if the number under the square root, so here's type 1, which is going back to this part. If the number under the square root is positive, so that's b squared minus 4ac. So if the b squared minus 4ac is greater than 0, then we're going to have two real solutions. Second part, if b squared minus 4ac is less than 0, then we're going to have two complex solutions. Just a reminder, complex numbers are in the form a plus bi, where you have a real part and imaginary part. It's okay, sometimes that imaginary part can be 0. And then the third is if b squared minus 4ac equals 0, then you're going to have one real solution. So example 3 says describe the nature of the solutions for each equation. So then when it asks for the nature of solutions, what they're asking, let me highlight this, when they ask the nature of the solutions, what they're asking is how many and what type. They don't care what the solution is, they just want to know how many solutions are there going to be and what type. So that's when I need to use the discriminant. So use discriminant. All right, so the discriminant, the formula for the discriminant is b squared minus 4ac. So b squared minus 4ac, so the a is 16, the b is 8, and the c is 1. So b is 8, so b squared would be 64 minus 4 times a, which is 16, times c, which is 1. So let's see, what is 64 minus 4 times 16 times 1? I'm getting 0. And so since my discriminant is equal to 0, come back over here, pen. That's 0, yes. So since my discriminant is equal to 0, that means I will have one real solution. I haven't figured out what the solution is, I just know that there's going to be one solution. Part B says I've got 2x squared minus 5x plus 6. I want to know how many solutions and what type they're going to be. So I'm going to find the discriminant, which is b squared minus 4ac. A couple glitches here. Let's see, so a is 2, b is negative 5, and c is 6. So b squared, negative 5 squared is positive 25, minus 4 times 2 times 6 So that would be 24 minus 4 times 2 times 6. Let me grab my calculator. Typing in 24 minus 4 times 2 times 6. I'm getting negative 24. Which is negative. So if my discriminant is negative, I will have two complex solutions. Now I want to work a couple from the problem set at the back. So turn your workbook, maybe I think 2 pages to where you get to questions like number 32, and you'll have some like this in your Math Excel assignment. And also the ACT and standardized tests, they love, so ACT, SAT, they love these types of questions where they put a variable in for one of the either A, B, or C values, and they'll say, okay, well, what would K have to be in order for it to do something? So in this case, we have a quadratic formula or a quadratic function, and we want to know what does K have to be in order to get one real solution. They don't want to know what the solution is. They want to know what number would have to go here in order for this whole equation to have just one solution. So I know in order to have one solution, let me scroll back up. In order to have one solution, I need to have b squared, the discriminant part, which again is going back, the discriminant is the part under the square root. I need this part, the b squared minus 4ac, to be 0 in order to have one real solution. So to have one real solution, that means I need b squared minus 4ac to equal 0. So then I'm going to substitute in what I know. Well, I know that A is 5. I know B, well, I don't know B, but we're going to say B is K, and I know C is 5. So I'm going to substitute what I have in for A, B, and C. So K squared minus 4, let's see, A is 5 and C is 5, equals 0. So then I have K squared minus, now 4 times 5 is, I think 100, but I'm double checking with my calculator. Yep, it's 100. So K squared minus 100 equals 0. So then if I subtract 100 on both sides, K squared be 100. Take the square root of both. K would have to be plus or minus 10 in order for this to have one real solution. So if I had the function 5x squared plus 10x plus 5 equals 0, that would have one real solution, or 5x squared minus 10x minus 10, that looks like 110, but minus 10x plus 5 equals 0. Each of these would have one solution, not two. Now on 33, I'll get a different color this time. 33 says, find out what K would have to be in order to have two real solutions. Well, to have two real solutions, then I know that the b squared minus 4ac part would have to be positive because, let me scroll up, to have two real solutions, b squared minus 4ac has to be greater than 0. So this number under the square root needs to be positive. And the number under the square root again is b squared minus 4ac. So b squared minus 4ac needs to be greater than 0. So b, and then we know that a is 3, b is 12, c this time is k, so I'll substitute in what I know. 12 squared minus 4 times 3 times k has to be greater than 0. 12 squared is 144. minus 12k would have to be greater than 0. I can, let's see, let's subtract the 144 on both sides. Negative 12k would have to be greater than negative 144. And then if I divide both sides by negative 12, anytime you divide by a negative and you have an inequality, you've got to switch that inequality. So k would have to be less than positive 12. So any number less than 12 right here for that constant will give me two real solutions. In the next example, your workbook is actually missing a little bit of information because it just says, according to the model of Rachel's serve, will the ball reach a height of 3 meters? And they totally left out like anything about Rachel or the model. So you do need to write this model down right there. And h is the height in meters of the ball. And t is the time in seconds after she served it. So the height of her ball is following this pattern. It says, according to the model of Rachel's serve, will this ball reach a height of 3 meters? So when they say, will it reach a height of 3 meters, they want to know, will h ever equal 3? So I can take this model and put a 3 in for h and have this equation: 3 equals negative 5t squared plus 5t plus 2. Now there are a number of ways that I could figure this out. I could just solve it and tell you and find a value for t. Finding a value for t would tell me the time when Rachel's ball would actually hit that height. So I could totally do that. I could use quadratic formula and solve and find the time that would happen. And then if I were to get an imaginary time, then that would mean it didn't happen. So that's one option. Another option is to graph it and see if this model ever does hit 3. That could work too. But it does say interpret the discriminant. So let's look at how I could use the discriminant to figure this out. Well, the discriminant tells me if there's going to be a solution or not. And to use the discriminant, I need the form ax squared plus bx plus c to be equal to 0. So let's rewrite this so that I have a 0. So I'm going to subtract 3 from both sides on the like terms. So 0 equals negative 5t squared plus 5t minus 1. So if I use the discriminant, what I'm going to say is there a solution? Or in other words, is there a real solution? Because a real solution would mean that the ball did hit 3 meters. An imaginary solution would mean that it would not. So I'm going to try to figure out if there is a real solution. So let's find the discriminant, b squared minus 4ac. So a is negative 5, b is 5, c is negative 1. And if we hadn't rewritten it in this form, then my a, b, and c would be off. They would be incorrect. So b squared minus 4ac. b squared is 5 squared, which is 25, minus 4 times negative 5, times c, which is negative 1. So that'd be 25 minus 20, right? Because that would be negative 20. Yeah, 25 minus 20 is 5. And so I get 5, which is a real number, or which is positive. And since the discriminant is positive, that means I'm going to have 2 real solutions. So will Rachel serve, will the ball reach a height of 3 meters? Yes, it will happen. Twice. So that's how the discriminant can tell me that. If I were to graph this, because why not? I have Desmos pulled up. Let me just pull Desmos right over here. All right, so what I could do with Desmos is I could type in Rachel's model, but I need to use x's and y's instead of h's and t's. So y equals negative 5x squared plus 5x plus 2. And then, so that's Rachel's model, and I want to see if that ever hits 3. Oh, I should type in y equals 3 to make it align. Does it happen? Oh, look, it happened twice. Now, the question doesn't say when does it happen, it just says does it happen. So that's why we can use the discriminant. If it had asked me for a specific time, I would have had to have actually solve it and do a little bit more work. All right, then example 5 says use the discriminant. Example 5 says use the discriminant to find a particular equation. Determine the value or values of b that ensure that 5x squared plus bx plus 5 has 2 non-real solutions. So if I want to have 2 non-real solutions or 2 complex solutions, then that means my discriminant must be less than 0. Because as a reminder, that goes back to have 2 complex solutions, I need the number underneath to be negative, and the number underneath is b squared minus 4ac, which is the discriminant. So I need, there we go. So I would need b squared minus 4ac to be negative or less than 0 in order to have 2 non-real solutions. The b is b, so b squared minus 4, a is 5, and c is 5. So b squared would minus, let's see, 4 times 5 is 100, yes, 100, again, 100. So b squared minus 100 would have to be less than 0. And then let's see, to solve this, I can look at the graph. And instead of b, I'm going to use, I'm going to graph y equals the left side and y equals the right side. So y equals, instead of b, I'm going to use an x squared minus 100, and y equals 0. I'm going to have to zoom out a little bit. All right, so it's saying when is b squared minus 100 less than 0, or when is it negative? It's negative in between negative 10 and positive 10, so this graph is negative all the way from here. And if I zoom out, I'll see a parabola. Negative from negative 10 until positive 10. So the value b that would ensure that that equation has 2 real solutions are all the b's that are between and included, negative 10, less than b, less than 10. All the values in between negative 10 and 10. So why is the quadratic formula helpful? It's helpful because we can solve for quadratic equations without having to complete the square. It works all the time. It's just a lot of steps to do. But we can also use it to tell you how many and what type of solutions we'll have. So good luck on this assignment. If you need anything, as always, please reach out. Have a wonderful day, and go Generals.